my name is Mayukha Vadari. I'm a software engineer at Ripple on the interoperability team. I mainly focus on interoperability developer tooling. This talk will be focused on the new sidechain design that we released last week, and we'll conclude with a demo of some of the new tooling. Just to get a little bit of a baseline, how many of you have already read through that design that we published last week? Okay. Just to, got to know where the audience stands. I'll start with the basics since this talk is called Sidechains 101. What is a sidechain? Well, a sidechain is a blockchain. It's an independent ledger that is parallel to the main chain, and it has its own consensus algorithm. This could be the XRPL consensus protocol. It could also be proof of work or proof of stake or something else entirely. It derives its value from the main chain. So all the value that is on the sidechain comes from the main chain usually. It can have custom features, basically whatever you can possibly think of. And you're not limited to just the features that are already on the main chain. And the way that you get your value to and from a sidechain is via a bridge, which I'll explain in a second. What are sidechains useful for? Well, maybe there's a new feature that you want on XRPL mainnet, but it's not approved yet. It hasn't passed the amendment process. Well, you can put it in a sidechain, and then people can already use it with their money on the XRPL sidechain by just transferring it over to the sidechain, interacting with your new feature however you want, and then bringing their money back to the mainnet whenever they want. One example of this could be something like hooks, which will probably take a while to get approved after the amendment is released. Another example is custom features that aren't really ever appropriate for the mainnet. Like, for example, EVM support. That's probably never going to come to the XRPL mainnet, but people do want it in the XRPL ecosystem. And so for that purpose, you can have an EVM-based sidechain. And lastly, we have private blockchains. For example, CBDC ledgers. Central banks can use sidechains for working with their digital tokens. Now, what is a bridge? So a bridge is basically how you transfer value to and from a sidechain. So let's say chain A is your main chain and chain B is your sidechain, and you want to transfer value to and from that. Well, there's kind of two steps in this transfer. First, you lock your XRP on the main chain, let's say 10 XRP. Then you can receive 10 issued wrapped XRP on the sidechain. Usually there's some piece in the middle there that kind of establishes that you have indeed locked your XRP on the main chain so that you receive your XRP, your wrapped XRP on the sidechain. And then you can do the same thing in reverse. You can redeem or burn your wrapped XRP and then receive your unlocked XRP on the main chain. And of course, that part in the middle is probably doing the same thing there, making sure that you really did redeem or burn your wrapped XRP when you receive your locked XRP. Now for the bridge design itself, the new design that we released last week. So just a little bit of terminology to make this explanation a little bit easier. The witness server is that piece in the middle that I mentioned in explaining what a bridge is. It is a server that essentially acts as, it essentially pays attention to these two chains, your main chain and your side chain, and it issues attestations for events. It attests that things happened. So this could be, for example, locking and unlocking or minting and burning. Then you have your source chain and your destination chain. A cross-chain transfer happens from a source chain to a destination chain. And some new terminology we have. Locking chain is the chain on which you unlock and lock your funds, and the issuing chain is a chain on which you mint and burn your funds. Now, usually the main chain is your locking chain and the side chain is your issuing chain, but that's not always true. Then you have a door account. Everything in the XRP ledger ecosystem is account-based. You have to have an account to do anything. Everything has to involve an account. So because of that, bridges also have to involve accounts. And so door accounts are those accounts. It's essentially the on-ramp to the bridge or something like that. It's one end of the bridge on one chain. So a little bit of a brief overview of the most important operation of a bridge, which is a cross-chain transfer. So first, you initiate a transfer on the destination chain. Then the user locks their or burns their funds on the source chain. Then the witnesses notice that the user has locked or burned their funds, and they issue an attestation on the destination chain saying that, yes, these funds can actually be transferred. And then once enough witnesses have attested to this fact, then the funds are automatically transferred. This is the normal operation of a cross-chain transfer. And all the witnesses are doing are they notice that you have locked and burned these funds, and that it is indeed a valid locking or burning, and it issues an attestation on the destination chain saying that this did happen, because the two chains can't really directly communicate. That's kind of how blockchains work. They're a bit of a siloed ecosystem. You need some other piece to kind of be an oracle and get information about what's happening on other chains. Now into the nitty-gritty, I'm going to go through these 7 new transactions that we have for what a sidechain for the new design. So first is creating a bridge. The transaction is called XChain create bridge, and it creates a bridge. You can see in the XChain bridge object, you have the 2 Door accounts on your locking chain and your issuing chain. And you have the 2 currencies, the locking chain on the locking chain and the issuing chain. So in this case, these are both XRP, but in practice, they might be different. Usually the locking chain would be maybe XRP, and then the issuing chain would be your wrapped XRP. The signature reward is essentially a fee for using the bridge. It's a reward to the signature providers or the witnesses for sending their signatures providing these attestations for you. And the minimum account create amount is the amount that it takes to create an account on the other chain. This isn't really useful for a typical transfer, but it is useful for account creation, which I will get to later. Next is XChain modify bridge. This is to modify an existing bridge. You can't modify the Door accounts or the currencies because that's kind of the identity of a bridge. So if you modify those, then your bridge doesn't really make any sense for that to be the same bridge. But you can modify the signature reward and the minimum account create amount. This might be useful if, for example, the account reserve on the opposite chain changes and you need to update that in your bridge. Next is the first transaction that is a part of the cross-chain transaction, cross-chain transfer, and that is XChain create claim ID. This basically kicks off a cross-chain transaction by creating a cross-chain claim ID. A cross-chain claim ID is kind of like a cross-chain transfer ID. It's created when you start a transfer, and it's destroyed at the end. The purpose of this is to prevent people from claiming the same funds twice. If you've locked, say, 10 XRP, then you only want to issue 10 wrapped XRP. You don't want people to issue 10 wrapped XRP twice or more or something like that. It's essentially the bridge version of the double spend problem. And this is our solution to that. And so basically you have the 2 parts are the other chain source, which is what is the account on the source chain that you want to be able to lock or burn these funds? Where do you want these funds to come from? And then you have the signature reward, which is basically, you're paying the bridge fee when you do this transaction. And you're just saying, yes, I know how much this costs. Yes, I'm paying the fee to use this bridge. Next, you have XChain commit. This is where you lock or burn your funds. And of course, it happens on the source chain. And there's an amount that you want to lock. There's a corresponding cross-chain claim ID for this particular transfer. And there's the other chain destination. Where do you want these funds to go? This last one is actually optional. You can leave it out, and I'll get to how you can actually still receive your funds, even if you leave it out in a sec. Then there's XChain add attestation. For most users of cross-chain bridges, you will not need to use this at all. This is done entirely by the witness server. So the witness server submits these attestations basically saying that you've locked or burned your funds on the source chain, and these attestations are submitted on the destination chain. So an attestation corresponds to a bridge, and it's got claim attestations, which are essentially your cross-chain transfers, and it's got create account attestations for account creations. I'll get to account creation later. This is what a claim attestation looks like. It's essentially the witness is signing a proof saying that, yes, you did commit those funds on the source chain. So it's got the account that did the committing, the amount that was committed, the attestation reward account, basically what account deserves this witness's share of the signature reward fees, the destination account, which, as I mentioned earlier, was optional. The public key and signature is the actual signature, of course. And was locking chain send is essentially just a Boolean that's telling you which direction this transfer is happening in. Is it from the locking chain? Was it sent from the locking chain? And then the exchange claim ID, of course. The next transaction won't be necessary in most of these cross-chain transfers, but let's say you leave out your destination account in your exchange commit, or you are unable to automatically transfer for funds on all of the attestations being received from the witness server. Maybe the destination account doesn't have the proper trust line set up or something like that. So in that case, you need this exchange claim transaction, which is submitted by whichever account holds the cross-chain claim ID. And basically, all it does is it's got a destination and it's got the claim ID, and you can just say where you want the funds to go. It's to make sure that even if something goes wrong with your funds transferring, you still have some control over it. So now account creation. You'll notice that accounts that cross-chain transfers start on the destination chain. Well, how do you start on the destination chain if you don't have an account on the destination chain yet? Well, that would be with this extra transaction, the exchange create account commit. Basically, it's pretty similar to an exchange commit transaction, except it's you have to include the destination, and it creates the account when you submit this account. And this is another transaction that the witness servers are listening to. And so this is what those attestations look like. It's pretty much the same thing. The only difference is the exchange account create count, and that's basically the equivalent of the cross-chain claim ID for account creation. And those happen a little differently. So now that we've covered the nitty-gritty of the transactions, let's step back and look at some overall flows. First off, how do you create a bridge? First, you submit the cross-chain create bridge transactions on both chains. Then that basically establishes what your DOR accounts are, what the currencies are, what the signature reward is, all of that. Next is the signer list sets. That establishes what the witnesses are. A signer list set transaction, for those who don't know, is basically setting up multi-signing on this account, on the DOR accounts. So the multi-sign will set up, the multi-sig will be the witness server public keys. And you can set up quorum however you want with whatever weights for whatever accounts that you want. Next, you disable the master key. This ensures that the funds truly are held only in the hands of the witness servers. And the witness servers control all of the funds in the DOR accounts, because that's kind of what their job is to direct those funds. Next, we have cross-chain transfer. So first, you submit a cross-chain create claim ID transaction on the destination chain, which kicks off your cross-chain transfer. Then you submit the cross-chain exchange commit transaction on the source chain, actually committing your funds. Then you submit the exchange then the witness servers submit the exchange add attestation funds for you. And usually that's where it ends. And once quorum is reached, and enough witness servers have submitted their transactions and submitted their signatures, then the funds will automatically transfer. But as I mentioned earlier, sometimes you need the exchange claim transaction to finish off the transfer. Next is account creation. This is pretty straightforward. You create an exchange, create a count commit transaction on the main chain, and on the source chain, usually the locking chain, and the witness servers will create the exchange attestation transactions on the issuing chain, and that creates your account for you. I have a couple minutes for questions before I move on to the demo.
Any time-based, any need for us to understand timeouts at any stage as you go through the process?
The question was if there are any timeouts or time worries when you're doing this transfer. The answer is no, because of this cross-chain claim ID. So as long as that object exists, the transfer can happen. And once that transfer happens, that object is deleted, and it just stays on the ledger until that transfer finishes. One more question?
I have a question.
Yeah.
So for the witness server, if it's multiple side chains, can the witness server be like the same host for multiple chains at once?
The question was, can the witness server be the same host for multiple chains at once? So the witness servers are really specific to bridges, not chains. So they're pairs of chains and only for those currencies. I mean, at the moment, witness servers can only support one bridge, but that could certainly change in the future because it's just additional new features. The question was, is the fee split among the witnesses? Yes, it is. That signature reward is split among all the witnesses that provide you these attestations to allow you to transfer those funds.
Does this work only with XRPL-based sidechains or other chains involved?
The question was, does this work with only XRPL-based sidechains? At the moment, yes, but you certainly could create a smart contract and modify the witness server to do something with, say, an EVM-based chain. I'll hold off on questions for now, but there should be time for questions at the end as well. I just want to get to the demo as well. So in terms of tooling, how do we make this easier for you to work with? Because it can be a little complex. Well, there's betas out for XRPL Pi and XRPL JS that have these new features, that have all these transactions, modifications to the requests, all of that built in. Then you have, there's Explorer support, which is in progress. I will demo it a little bit later. And there's the Sidechain CLI. This is a new tool. Some of you might be familiar with the Sidechain launch kit that was released last year. But this is kind of a new version of that. It's very different, but it serves the same process. It serves the same job of making it easier to do that, to work with sidechains, to do these cross-chain transfers, all of that. Now for the demo. Cool. So first off, to use this Sidechain CLI, you got to export some environment variables. I have this already done, but here they are just to show you. Xchain configure is, you got a bunch of config files that you need to create. So where do you want all of this stored? RippleD.exe is the executable for RippleD, and witness.ext is the executable for the witness server. You have to install those yourself right now onto your whatever machine that you're using in order to use this tool. So first off, let's create some config files. So this is the Sidechain CLI. There's some nice help methods here that show up for you. Now, I want to work with some servers. What can I do? So that's the list of all the operations that I have for servers. And I want to create some config files. And now those are created. And if I look into my Xchain config directory, I now have these files. So there's a folder for each of the two chains that I need, which is the locking chain and the issuing chain. And there's a folder for each of the witnesses. This creates 5 just because. So if I look into the locking chain, it's got the database folder and RippleD.cfg, just whatever you need for RippleD, basically. And if I look into one of the witness folders, then it's pretty much the same thing, but for witness servers instead. And let's take a quick look at the witness config files. This is just a simple JSON. It's got information about the locking chain and the issuing chain, how to submit things on the account, and how to sign things, essentially. All the information that the witness servers need. So now that we've created these config files, let's actually start up all of these servers. We can do that with start all. And so now it's starting up all of these things. I don't know why, but every time the witness servers are started up in a different order. Yeah, so now we have all of these servers started up. You can check out the list of servers. This looks terrible in this zoomed in screen, but all the data is there. And next up, we can actually check the status of these servers by printing out the output. So let's say I want to look at the output of the locking chain. And for those of you who have run standalone nodes before, you'll know that this is pretty much what it looks like when everything happened successfully. And so yes, I know that all of these servers were started up successfully and they're running and everything. Now we can actually create the bridge. So how do I do that? So I want to create this bridge. First I got to create it and then I build it. So let's call it bridge. I'm very original. And it's between the locking chain and the issuing chain, and it's got these witness servers by name. What? Chains. There we go. And so now that's been created. And now before we can actually build it, the locking chain, the locking chain and the issuing chain door accounts need to be created. And so that's stored in this bridge bootstrap file, which is called that because you can use it to kind of bootstrap your bridges. And so here we have the locking chain door and the issuing chain door. The issuing chain door already exists because this is the Genesis account. The locking chain door needs to be created. So we can do that with this method called fund. So it's on the locking chain and the account is this value. And so that's now been created. And so now we can actually build the sidechain. And so I need the bridge, which is bridge, and the bootstrap file. And let's print that out verbosely. So it does the exchange create bridge transaction, it does the signer list transaction on both of the two chains. It doesn't do the disable master key because because this is only happening locally and it's easier to modify the door accounts as necessary if it doesn't already have multi-sig set up on it. And it's also initialized all the witness reward accounts. It just basically funded those two to make sure that those exist. And so now we can actually transfer. So in order to transfer, we need an account to transfer to and an account to transfer from. So we can run a wallet propose request on the servers to kind of generate two accounts to use. And we can send from the first account to the second account. So first off, these accounts need to exist. Great. And now this other account has to exist. Now that these accounts exist, we can actually do the transfer. So that's done with this bridge transfer method, which you pass in the bridge, the source chain, it's from the locking chain, the amount. That's 1 XRP, let's do 10 XRP. And now we want to do it from this key to this key. But before I actually hit enter on that and make that happen, let's pull up the Explorer. And we can see that it's been paying attention to all of these transactions, and yes. But we can take a look at the accounts that we're transferring between. So this is on the locking chain. This is too zoomed out. So it has 1,000 XRP, as you can see. And then on the issuing chain, we have this. This also has 1,000 XRP. So now let's actually do this transfer. I have a tutorial mode that kind of goes through everything step by step. And I typoed again. So first off, we create a cross-chain claim ID on the destination chain. And this was successful. Next, we lock the funds on the source chain, which does the exchange commit transaction. This is also successful. And then now we wait for these attestations on the destination chain, and they have all come through, all 5 of them. So now we should see that this balance has gone up by 10 XRP, and this balance has gone down by a 10 XRP. And you can see that the exchange commit transaction is here, and the exchange add attestation transactions are here, and the create claim ID is here. So that's pretty much how a cross-chain transaction happens with this, a cross-chain transfer happens with the sidechain CLI. Now let's actually create an account. So we can create another wallet propose. And let's create this account. So there's this method for that, create account. The to chain is the locking chain. The bridge is bridge. It's from, gotta scroll all the way back up now. It's from this account, and it's to this account that we just calculated the keys for. And before I hit enter on that, let's make sure that this account does indeed not exist yet. And account not found. So after this, the account now exists and has 5 XRP. That's pretty much all I got for the demo.